everyone. My name is Mr. Amoyavi, and I am one of your grade 12 advanced maths teachers. In our last lesson, we talked about the nature of stationary points. Right. In today's lesson, we are going to talk about maxima and minima. Maxima and minima. Right, as you can see, I have a diagram here on my right already, and that will be one of the examples that we are going to look at to calculate the maxima and minima. So what is actually a maxima and what is a minima? All right, they're actually the y coordinates of the stationary points or the turning points that we have looked at in our previous lesson. Right, so what we will do is when we calculate the y coordinate of the stationary points, we are going to calculate the maxima or the minima. Now, the example here is, if I have a square metal sheet of size 6 meters, 6 meters, 6 meters, and if we have to cut out a square of x units from each corner here, and we have to fold along this line and this line to form a rectangular tank like this. So if you have to fold it up, then this x now becomes the height, and we have the length and the width. So from this, we know the volume of this tank here will be given by, again, we know the volume of a rectangular prism is given by the length times the width times the height. Or we can say in reverse, height multiplied by the length multiplied by the width. So if I look at this diagram, the height is x multiplied by the width is 6 minus 2x multiplied by another 6 minus 2x. Right, so the rest of the thing that our process is to just expand and collect like terms. So it will be x multiplied by 6 times 6 is 36. 6 times minus 2x will be minus 12x. Minus 2x times 6 gives us minus 12x, and this minus 2x times minus 2x gives us positive 4x squared. Right, so we have x multiplied by 36. Collecting like terms here gives us minus 24x plus 4x squared. Finally, we are going to expand it with x here. So x times 36 is 36x. X times minus 24 will be minus 24x squared. X times positive 4x squared gives us 4x cubed. Right, so what we have here is the volume, expression of the volume of this tank. Now, in order to determine whether, or determine the volume, the maximum or minimum volume, we have to take the derivative of this function here. So dv over dx will be equal to, if I have to take the derivative of this, it will be 36. Derivative of this part, it will be bringing the 2 in front. Actually, we are applying the rule for differentiation. So 2 times negative 24 is 48x. Then we subtract 1, it becomes 1. And then taking the derivative of 4x cubed, we get 12x squared. All right, we know at the stationary points in our previous lesson, the gradient or the rate of change function is equal to 0. Therefore, we are going to express this or equate this to 0 and solve for x. Right, so if I have this, it's a quadratic expression, but we can rewrite this and say 12x squared minus 48x plus 36 is equal to 0. Now, when we look at the terms here, the highest common factor seems to be 12, so we can take, to simplify our expression to solve the equation, we can take the 12 outside and we say 12 divided 12x squared is x squared minus 12 times 48x gives us 4x. 12 divided 36 gives us positive 3 is equal to 0. If you have to divide 12 on both sides, 12 cancels out here, and 0 divided by 12 will be 0. So we're left with x squared minus 4x plus 3 on the side of the equation. Right? The rest is, look at this expression. It's basically a simple quadratic expression that we have learned to solve in grade 11. So the two factors of positive 3 that gives us a sum of minus 4 will be x minus 3 and x minus 1. Right? So minus 3 times minus 1 gives us positive 3. Minus 3 take away minus 1 gives us this. So these are correct factors. Therefore, now the value for x, by using null factor law, x minus 3 will be equal to 0, or x minus 1 will be equal to 0. All right. So what would be the value for x? We just take the negative 3 over to that side. X therefore is equal to 3. If I take the negative over, it becomes positive, so x equals 1. Now, what are these values of x? They're actually the x coordinate of the stationary points. Right, so if you want to find a y coordinate or the value of v, then we have to take this and substitute in the volume function here. So when we substitute x equals 3 in this function here, volume will be equal to 0. Right, if you have to substitute x equals 1 in this function here, the volume will be 24. Now, as you can see, compare this, you can see that the maximum volume will be 24 when x is equal to 1. So we can say that x is the value of 1 is the value of x that will produce the maximum volume, while x equals 3 will be the value of x that produces the minimum volume. But we can also prove this using the idea that we already have learned in our previous lesson. So if I have to take, let's say, x equals 1, and prove that I have x equals 1, 1, 1. We consider a number greater than 1, a number less than 1. And then we consider the sign of the differential coefficient or the gradient function, dv over dx. If I have to substitute some values in this gradient function, a number less than 1, let's say try substitute 0, right? If you have to substitute 0 in this gradient function here, you will get 0, 0, and then 36, which is positive. So here we have positive. If I substitute 1 into this function, I get a 0. If I substitute a number greater than 1, let's say 2 or 3, you will end up with a negative answer. So you look at this pattern here, you will get something like this. Okay, a positive, 0, and negative. And that this shows us that this x equals 1 produces the maximum volume of that box there. Therefore, we can say x equals 1 produces the maxima, while x equals 3 produces the minima. All right, so what we have actually learned is we apply the idea of the derivative and the nature of turning points to calculate the maxima and minima. And again, the maxima and minima are actually y coordinates of the turning points. Right, so what we have done is we have looked at this example. We have a square metal sheet, and then we cut out a square is from its corner, and we form a tank. So we formed, and then from there we formed a volume of that tank, and we take the derivative. We equate the derived function to 0, and then we calculated the values of x. That will produce either the maxima or minima. And we have proved that this point here, x equals 1, produces the maximum volume. Thank you, everyone. In our next lesson, we'll talk about the product, quotient, and chain rule.